Hello and welcome to Learn Data. I'm Nilesh, and in this video we'll continue learning more about pandas and talk more about categories. Specifically, we'll be talking about how to sort and order categories, then how we can get the min and max of a particular category. We'll also look at how to reorder categories and how does this category work when we are sorting columns. Finally, we'll look at how we can compare either order category with the ordered category and an unordered category with another unordered category. So let's get into Jupyter notebook and start coding. I've already created a new notebook and imported two libraries. Probably we don't need the matplotlib here. So we need NumPy and Pandas. And for data, we are going to create the series and data frames as we go on, but for now we'll go ahead and get started with this one series which has 4 elements in it and it has a data type of category. So this series has 3 categories: M, N and O. So to begin with, we'll talk about sorting and ordering. So how does that work and how we can work with a series in this case. So the series that we have, as we see above, is A, and it has M, N, O and M as elements in there, which are the categories as well. Now if we were to sort this, so if we say A dot sort underscore values in place is equal to true, what in place does is we do not have to, it is equivalent of typing this. So A is equal to A dot sort values, and if we were to do this, this is equivalent of saying in place is equal to do. So we do not have to specify this A is equal to in before that. Now when we sort these and then there's a sort values, sorry. Now when we sort these and look at A, we can see that the categories were sorted according to the alphabets M, N and O. There is no specific sorting, there is no specific ordering for each of these categories. As we can see here, they are separated by commas. So the way the sorting was done in this case was in lexical order, or by the order of the alphabets. M comes before N, which comes before O, so M, N, O, it has sorted in that order. Now here we can change this behavior. We can go and explicitly specify a particular type of ordering for each of those categories, and what we can do is say A is equal to A dot cat dot as underscore ordered. Now when we specify this, we now have provided an order to all the categories. So M is less than N is less than O. So this is a new set. Now if we look at A dot min, we can get the minimum category, which is M. Similarly, if we type A dot max, we can get the max category, which is O in this case. If we now go ahead and remove the ordering from the series, let's say we say A is equal to A dot cat dot as underscore unordered, and then look at A, we have removed the order that we had created earlier. So as you can see that M, N and O are now separated by commas and not by these less than signs. So if we were to try to get the min of the categories now, we'll get an error, as we can see here, and the error says categorical is not ordered for operation min. So you can use dot as ordered to change the categorical to an ordered one. So if we were to change this to ordered and run this again, then we would be able to get the min and max of that for that particular series. Next, let's look at another series. So we'll use the categorical D type in this case we'll go ahead and create a series a pd.series, and here we have m, n, o, and then finally we have another m, and this is going to as type categorical data type, and we are going to specify ordered is equal to true, and we look at a. Okay, the reason why we get this error is because I forgot to import the file library, so we need to import from pandas.api.types import CategoricalDtype. Now this will work. So here, as we can see, the categories are now ordered, where M is the smallest category and O is the largest category. Here, if we now go ahead and sort this particular series, so if we say a.sort underscore values in place is equal to true, in this case now the ordering would be in the order of the categories and not by the order by the way the alphabets appear in the series. So as you can see, M here M is the smallest and therefore it appears first, N and O. However, that could be changed. So let's say we can specify a separate order as well to each of these categories. So what we can do in here, we can specify the order in which we want it. So if we say O and then specify M and then specify N, now what will happen is we have changed the order. So now O is the smallest, M is in middle, and N is the largest. Now if we sort the values and look for A, this time we can clearly see that the sorting is done by the value of the category and not by the value of the alphabet or the lexical value. Earlier we had M as the top on the top as the smallest category, but now O is on the top, which is the smallest category as specified here. Moving on, we can also get the min and max. So if you type a.min, we get O, which is the smallest here, and if we type a.max, we get N, which is the largest category in this case. We can also use the same commands that we used earlier by removing the order for the series. So if you type A is equal to a.cat.as underscore unordered, so we are removing the order for the category. As you can see here, the less than signs are now gone, they are replaced by commas. Now if we try to find the min for the category, we are going to get an error as we expected, and the error specifies that the categorical is not ordered and we need to use the as underscore ordered to be able to use this function mmin. So if we go back here and change that unordered and run this, then we are able to get the a.min value. Moving on, let's look at how we can use the reordering of the categories. And for reordering, we are going to go ahead and create another series. A is equal to pd.series, and we'll create numbers this time, 1 2 3 and 1, and the data type would be a category. And when we run this, we can see that this is an unordered category because we do not have the less than signs here, we just have commas. Now what we can do is assign an order to this particular all the categories in this particular series, and to do that we'll use the same method that we used earlier, which is A is equal to a.cat. Now the difference is here where we type reorder underscore categories, and here we can specify the order. Let's put 2 as first one, 3 as the second one, and 1 as the largest category. And if we specify ordered is equal to true and then look for A, we can see that although as a number 1 is smaller than 2, but in this case, because it's a category and we have specified the order in such a way that 1 is the largest category, therefore 1 is larger than 2 in this case. And to check this, we can also do a sort on a. So if you do a dot sort underscore values in place is equal to true, we can see that series has there's a dot sort values. I did this mistake earlier. Okay, when we look at a, we can see that the sorting is done by categories. So because 2 is the smallest category, it appears first as a first row, and 1 is the largest category, and therefore it's towards the bottom here. So that's the difference between ordering and not ordering, ordered versus unordered dataset. Here, because we have an ordered dataset, we can get a min of that dataset. So here the minimum value is 2 and maximum value is 1. That is counterintuitive, but because we have manually specified the order to be such that 1 is the largest category, therefore we have a dot max value which is equal to 1. Now let's look at how we can work with multidimensional data, which would be a data frame. Now I'm going to create column here, multi columns. Let's create a data frame df pd.dataframe, and in here we'll create 2 columns. A column which is equal to pd.categorical list, and here we are going to create values by just creating a string n mm m, and this is then going to have categories as well. And for categories, we have we'll put the category O as the smallest, and then followed by category N, and the largest category that we have is M. Finally, we have the column B, which has numbers in it. So 1, 2, 3, maybe 2, 5, 3, and maybe 1 again. So these are the columns we have for this data frame. Here now what we can do is we can check the data types of this data frame. So here we can clearly see that the column A is a categorical column, and if we now go ahead and sort this, so if we say df.sort underscore values and we specify the names of the column, by is equal to A, and then first sort by A and then sort by B. So when we sort by A, we are not sorting it by the value of the alphabet or lexical order. So we are not thinking here that M is the smallest because it appears before N, and O is the largest because M, N, and O, that's the alphabetical order. But in this case, because we specified the categories here explicitly and have given them an order where such that O is the smallest and M is the largest, therefore when we sort the values in that data frame where the column A is the first sorting column, we have the smallest category O, which appears on the top, and the largest category M, it appears at the bottom of the data frame. Moving on, we can change the order similar to how we changed the order in the series that we saw earlier. We can go ahead and change the order of the column A. So to do that, we would type df of A is equal to df A, and here we can type .cat reorder underscore categories, and we can specify the name, the change in the order here. So why don't we make M as the smallest, and let's say we make O as in middle and N as the largest category. Now when we look for df and sort these values for df, so let's try that. Df is equal to df dot sort underscore values by is equal to a comma b. And now when we look for df, we see that M, which is the smallest category, appears on the top, and N, which is the largest category, appears at the bottom of the data frame. So that was how we could order and work with multi-columns, where in a data frame you have categorical column along with the normal data. Let's now look at how we can compare categories and see how it works. So for this we are going to create three series. The first one is pd.series, and here we'll give values, let's say 7, 8 and 9, and this would be as type CategoricalDtype, and we can specify the order for the categories. Let's make 9 as the smallest number, smallest category, and 7 as the largest category. And we also go ahead and specify ordered is equal to true, so that we can do the non-equality comparison such as greater than or less than. And if we go ahead and now look at A, this is how it looks. Similarly, we'll go ahead and create A2 and A3. So for A2, we will go ahead and change the values here. So we'll make all of them 8. We'll keep the category and ordering the same. For A3, we will again go ahead and change this. However, we are not going to specify any specific ordering there, but we will make sure that it says ordered is equal to true. Now when we run this, the first difference we can notice is in this particular series we have 3 different types of categories. In the data set 7, 8 and 9, here although we have 3 categories, the data in the series A2 has only 1 category, and in the series A3, because we did not specify any categories in the categorical data type, by default it just took 1 category which was in the data set. Now if we do some comparison, so let's say if we try to see if the values in A2 are greater than values in values in A1 are greater than values in A2. In this case we can see that 7 is greater than 8. As a number it is not, but when we look at the category, 7 is greater than 8, as you can see here. Therefore that condition is true, all other conditions are false. As well, we can also look at, let's say A1 is greater than 8, if that is the case. Now in A1 again 7 is greater than 8, that is true, but 8 is not greater than 8, and 9 is not greater than 8 in this particular case where we have specified the order of each of those categories. Now we can also go ahead and change this to false. And let's see what happens if we change this to false. So now we do not have any order associated with these categories. If we now let's do that for A1 instead. Okay, now if we go ahead and run this same command to compare A1 greater than A2, we are going to get an error, and the error specifies that unordered categoricals can only be compared for equality or not. What it means is, because it is unordered, we can only compare using this sign, or we can compare using this sign. So equal to or not equal to. When we run this runs because in this case 7 is not equal to 8, but 8 is equal to 8, therefore we have a true here. Now for not equality, we can see that none of the values in a1 are equal to a number 2, and therefore it is all true. Again, if we specify a2 here, we can see that the 7 is not equal to 8 and 9 is not equal to 8, therefore those are come up as true here. We'll go back and change this to true as it was, and look at some other changes we can do. So true, and now if you run this will work. Here, as we already saw with unordered case, if we have the equality and the data set is already ordered, we still can compare it. So we can see that false, true, false, it works. However, these orderings in the series have to be in exact same order. Okay, if the numbers here do not matter as much, but these numbers here that are specified for the orders, they have to be in the same order and they have to be the same categories as well. For example, if we go ahead and change this to 9, 7, 8, if we do that and leave this as 9, 8, 7, now if we go ahead and compare a1 greater than a2, we are going to get an error, and the error says that categoricals can be compared only if the categories are the same. So this is my understanding that even though the categories are the same categories exist, the orders are not the same, and therefore they are not going to compare. Okay, now I'll go back and change that to 8 and 7. Let's now look at another comparison where we have the series A1, which we are going to compare with np.array, and this array has 7, 8, 9, which are the same elements that we have in the series A1, and when we run this, we get true for all of them because 7 is equal to 7, 8 is equal to 8, and so on. If we change this to some other number, it will still compare, and we get the false because 9 is not equal to 19. Similarly, if we change this to any just integer, say 8, we get false for the first and the last, but it is true for the index 1 because it has the value of 8, as we can see here, and therefore 8 is equal to 8, and it works out well there. Finally, let's look at another example where we are going to compare inequalities, as we saw earlier, using a new example where we have another data frame. Let's create a not a data frame but a series d1 pd.categorical, and here we are going to specify m and n, just 2 elements in there, and categories as m and n again. So the same categories that we have in the list before that we typed, and here we are going to specify that ordered is equal to false, and similar to this we are going to create another series d2. Here the only change we are going to make is the elements, we are going to switch the positions of m and n to n and m. Now if we run d1 and d2, we can see that it has 2 categories, m and n, both cases, and the orders are switched for the m and n in 2. Now if we compare a1 is equal to a2, d1 is equal to d2, like so, we can see that they do not so they are not the same, they are false because m is not equal to n and n is not equal to m, therefore we have the false. But the important thing to remember here is that we were able to successfully perform the operation of equal to. That was because we had set the ordered is equal to false. Okay, and that was the summary. Here if we change this to, and because this is false, we cannot compare d1 is greater than d2. That's not going to work, and we'll get the same error that we got earlier. Unordered cannot be compared other than for equal to or not. So if we change this to true, now if we run this to, then we can see that yes, when we compare these, m is now n is the largest in this particular case. So is m greater than n? No, because n is the largest, and second, n is greater than m, and therefore we get the output as true. So that was it for this video. I hope you learned how to sort and order categories and how to compare them either with the equality signs equal to, not equal to, or the non-equality signs, which are the less than or greater than signs. Thank you. Please like, share and subscribe. I will see you all in the next video. Thank you.